My name is Eyal. This is the Jacksonville Java User Group, our March 2022 meeting, an online meeting, and we have Reza Rahman from Microsoft, and what may have been sounded strange years ago that Microsoft is actually talking about Java is actually a reality now in the past few years at least, and we have Reza to talk about some of it. And I will leave the stage to Reza. Thank you for coming and of showing up, let's say. I think you may be mute still. I can't hear you.
Oh, thank you very much for having me. I really appreciate it. It's been ages since I spoke anywhere near Florida, that's for sure. So yeah, hopefully you guys are having much more wonderful weather than us up here.
Yeah, we have great weather today at least. So again, thank you, and I'll make myself invisible. Leaving it
Alrighty.
to you.
Okay, so thank you everyone for joining. As was mentioned before, my name is Reza Rahman. I'm in my day job, I'm principal program manager at for Java on Azure at Microsoft. So basically, I do all manners of Java stuff at Microsoft, as was pointed out, probably somewhat surprising to some folks, but not to us. The folks that have been working on this for a while, this is certainly no big surprise. So I will be working. Basically, today's talk is a microcosm of the work that I do. It's one aspect of our work, in particular, our collaboration with IBM around the WebSphere family of products. And I'll show you in a moment precisely what that means. But basically, I will be focusing on one aspect of that, and that happens to be Open Liberty, which is a next generation runtime, Java runtime from IBM, sort of a replacement to your old school WebSphere traditional, and frankly, it's a really fine runtime. I'm a fan of it for sure, and it's definitely underappreciated. So the people that we work with, that actually work with OSCR Liberty and Open Liberty, understand its value, and really understand how what a powerful platform it actually is. So I'll be talking about how to use that platform and combine it with yet another very interesting technology named OpenShift. So OpenShift is a Kubernetes-based orchestration platform. You'll see a bit of that. So my focus isn't solely on Liberty and isn't solely on OpenShift, but rather how to use these things together. That's what I'll be showing you in the talk today. And when I say show you, I really do mean that. So this is a completely slide-free talk. I have zero slides whatsoever. I will share some URLs with you that you can go explore. What I'll show you on your own. But today I don't intend to do any slides whatsoever. All I'm going to be focusing on is how to do this stuff. So I'll be doing a live demo for the next, let's say, 35 or 40 minutes or so. So the other thing I'd like to say is I'd like to keep this talk conversational, just in the spirit of live coding. So if you have any questions, just post it right away. I will intermittently check to see what's going on in the chat. So I will, feel free to ask questions as we go along, and I'll stop and answer them. And it'll give me a break from doing live coding for an hour. It can be strenuous at times. So all that being said, let me begin sharing my screen, and without further ado, let's start the coding. All right, so share screen. Share, and I'm going to hide this guy. Do me a big favor and tell me if you can in fact see my screen. So you should be seeing my search engine, my browser, and I have Google open. So just give me a thumbs up or something like that. Yeah, okay, brilliant. Thank you. I appreciate that. Okay, so where do we start? We start where most programming journeys start, with opening up Google and typing something. Okay, so in this case, we're going to type in WebSphere on Azure. Just simply two words, WebSphere and Azure. So once we do that, you will land on a page that we have on docs.microsoft.com that outlines the work that I talked about. And this is basically a partnership that we started with IBM, primarily because we observed that we have a bunch of joint customers. In other words, there's a bunch of people that are running IBM software, in particular the WebSphere family of products on Azure. And this is how we formulated this partnership. And we said, okay, how do we better serve these customers? So this particular graphic represents sort of the totality of our work with IBM around the WebSphere family on Azure. So we support WebSphere traditional, grand old WebSphere on virtual machines on Azure. We also support the newer generation. As I said, definitely a worthy runtime, and definitely I'm a fan of it. WebSphere Liberty and Open Liberty. But we don't really work to support those on virtual machines. You can run them on virtual machines if you so wish. But actually, Liberty is much more optimized and much more suitable. I'd say much more suitable than perhaps some of the other popular runtimes like the Tomcat and JT based runtimes for containerization. And you'll see that in a moment. You'll see that for yourself. So we do support these runtimes on our major container platforms, and on Azure, those are Azure Kubernetes Service and Azure Red Hat OpenShift. Now, aside from enabling all of that, we also enable a bunch of integrations. So when you're on the cloud, you want to move into more cloud native capabilities like database managed services, directory servers that are managed, and all manners of infrastructure that is actually managed on your behalf. And we actually make sure to enable all of those types of integrations with both WebSphere Liberty and Open Liberty, whatever your ultimate target runtime destination might be. So this describes all of the work at a high level, let's say at a bird's eye level that we do with IBM to enable with the WebSphere family of products on Azure. But today I'll be focusing on one particular, I would say, an interesting, relatively interesting combination, and that is running Open Liberty and WebSphere Liberty on ARO or Azure Red Hat OpenShift. So I think I gave you a bit of an introduction of WebSphere Liberty and Open Liberty. I'll show you WebSphere Liberty and Open Liberty in action. I'll explain a bit what Azure Red Hat OpenShift is. So OpenShift, I hope you've heard of it. It's basically a container orchestration platform. It builds on top of Kubernetes. So it has a Kubernetes runtime under it, but it's much more than Kubernetes actually. It gives over Kubernetes, as you'll see in a moment, you'll see for yourself if you have some experience in developing with just native Kubernetes. It's a higher level of abstraction. It gives you a much nicer console, which you'll also see in a moment, as well as more abstracted tooling on the same things that you would normally do with Kubernetes. So on Azure, we have a managed version of OpenShift. You can install and run OpenShift, in fact, even Kubernetes on your own, but it is not for the faint of heart. So what something like Azure Red Hat OpenShift does is that it gives you a managed versions of that runtime. You just point and click, and it creates that runtime for you. In fact, I'll show you a way that you don't even do that. You're even at a higher level of abstraction. You're actually at the Open Liberty on ARO level of abstraction, and you'll see what I mean by that. So there's a couple of different primary things that we do to enable this particular pathway. One is that we provide you step-by-step instructions on how to do this basically from scratch. Okay, so you're literally starting from absolutely nothing, installing the ARO, setting up the ARO cluster, setting up the OpenShift registries, setting up the namespace or project, setting up the operator, the Open Liberty operator, which I'll explain in a moment. It's an important component in all of this. But basically, you do all of these things by hand, and that's a fine pathway, right? That's often fine for many people. But this basically gives you the entire process end to end. But what we found while we were doing that, and this is what we produced first, is a lot of these steps are actually relatively boilerplate. So Azure has this mechanism called a Azure Marketplace Solution Template that actually solves this particular problem of taking a bunch of boilerplate provisioning time steps and abstracting them behind a facade. And in fact, this is what I'll start the demo today with you. But of course, if you prefer the more step-by-step approach, what I'm going to show you is just an abstracted version of that. You can always use the manual guidance to essentially do the same thing if you like, if you so prefer. So I'll show you the solution template. I can click on this and it'll take me directly to the Azure portal and directly to the offer. But actually, I prefer a bit more of a gentle approach, if you will. So this is the Azure portal. If you've never seen it before, this is basically the control panel, the visual control panel of doing all kinds of provisioning on Azure. Basically, you can get an Azure subscription for 1 year for free. One caveat, You will be able to run TWAS or Webster Traditional on VNs or Open Liberty and Webster Liberty on AKS just fine with the free subscription. ARO, you will not be able to do that, right? Because ARO has a 40 core requirement, and that is beyond the threshold of what we offer in the free tier. So you will need a paid subscription to do ARO. But if you're not doing ARO, free subscription is just perfectly fine. So how do you get started? Just like we got started in the web browser, you when you're in the Azure portal, you simply type in WebSphere. And believe me, this is gives me goosebumps when I do this kind of thing, because this was not possible. 5 years ago, this would have been unimaginable that you're on Microsoft's cloud platform and you type in something like WebSphere, WebLogic, or JBoss, and you're presented with some options of what to do. So in this case, there's 4 different options. These 2 options are basically Webster Traditional ND and Webster Traditional Base, respectively, on VMs. This is the offer that allows you to run Open Liberty and Webster Liberty on Azure Kubernetes Service relatively easily. And this is the offer that allows you to do ARO. So obviously, this is the pathway we are exploring today. So let's click on that. Once you do that, it'll take you to the offer. The offer has some nice stuff in it to explore the offer further, including a little video demo of what the offer does and some lightweight description and some documentation links. Okay, so let's skip over all that. I'll just hit create here. And once you do that, you're presented with a fairly simple dialogue, and we'll try to deliberately keep this relatively streamlined. So on the first screen here, you will choose the subscription you want to use, how you want to get billed. Could be a free subscription. Again, you'll choose a resource group, and resource group is really nothing much more than a collection of Azure resources. You can think of it as an application unit or a data center unit. And then you pick a region, and we have a number of regions on Azure. I would say Azure probably has the largest number of regions or data centers of all of the major cloud providers. So this next part is a bit tricky, and I'll explain this to you without going into very much detail. On Azure, everything is secure. So what that means is when we're doing something like a solution template that is creating a bunch of resources on your behalf, you need to be very deliberate about how those are created. So the way that this is managed, is that you need to specifically create what's called a managed identity and give that managed identity just the amount of permissions that you need to execute this operation on your behalf. Okay, so we tell you here how to create a managed identity and what specific role this managed identity needs to have for this template to execute. So I can just pick one from here. Let's pick Azure demo identity, and that's the managed identity that I created beforehand that has the requisite permission. So next, you will configure a cluster. You can either create a new cluster, and this will deploy a new ARO cluster on your behalf, or you can select to do your Open Liberty setup on an existing ARO cluster, and you can do that. Right? So you can pick an existing cluster that you've already created. Since this is using Red Hat software, you'll need to have what's called a Red Hat pull secret. You can get this for free. You can get, basically all you need to do is go and create an account on redhat.com, and you'll be given a Red Hat pull secret, but you'll need to supply that. And as part of our setup, basically OpenShift expects that you're going to be doing all of your work in a concept called project. Okay, so for that project, you need somebody that administers that project at the bare minimum. So over here, basically what we are asking you to enter is the credentials of the person that is going to be administering this project in a secure fashion. Okay. Finally, there's a configure application tab, and this is optional. In fact, for this particular demo, I want to keep it, and as you can see, the default is no. This is not sort of like a production workflow, if you will. And in a production scenario, you'll actually be doing something much more similar to what I'll be doing just in a moment. But yeah, you can optionally, when you are doing the initial setup, also deploy an application. So a couple of different ways of doing that. One is that if you already have an existing application image that refers to Open Liberty, you can feed it that. And as you can see, by default, we basically give you the empty. Okay, you can specify the empty Open Liberty image, and this is just Open Liberty running, no app in it. Or you can also, as a starting point, choose this sample app that comes from IBM that basically is a small sample that shows you the basic mechanics of getting Liberty running in a containerized fashion. Okay, so you can use that one if you so wish, and you can also specify the number of replicas. Now, I could have done all of this, but remember, ARO is not that trivial, right? So it's something that requires 40 cores. That takes some time to provision. So on average, this provisioning, once you hit review and create, will take somewhere between 30 and 45 minutes, depending on many different variables. So obviously, that's the duration of the talk. If I was very good at telling jokes or something like that, that would potentially work. Obviously, otherwise it wouldn't. So here's what I've done. I've earlier in the day-to-day, I've simply gone through this and I've created the resources on our behalf. So I'll go to my resource groups. I'll show you a few things that I created ahead of time. So here's the managed identity that I've created beforehand. And I've also created a database. We'll be talking to this database shortly. This is a managed database on Azure. It happens to be Postgres, managed Postgres. And this is where I created the actual ARO resources. So this is, if you will, the end output of me running my solution template. Okay, so what you get in the end is a VNet or a virtual network where you will be doing your deployment and an ARO cluster, or Azure Red Hat OpenShift cluster. But other than that, there's not anything too terribly interesting when it comes to ARO. For other Azure services, there's plenty of interesting stuff in the portal, not so much for ARO, because ARO, as I'll show you in a moment, has its own interface, has its own console, where a majority of the work is actually done. But this is what you get in the end. So there's actually a bunch of stuff that has happened behind the scenes, and I'll show you in a moment what all the stuff that has happened. So let me stop for a moment. I've been talking for a while now. Let me check on you to see if you have any questions. And yeah, if you don't have it now, again, this is an encouragement to post those questions as we go along. So no need to wait until the very, very end. Okay, so I do not see any questions just yet. So I think I'll just keep going. But again, I would encourage you to ask questions. Okay, so is this all we do? The answer is no, we do help you out a bit more. So if you go to deployments, and you'll see that there's a number of things that we have done on your behalf, but this is the one that has taken the longest, 40 minutes, as I said. In deployment took 40 minutes earlier in the day. But if you click on this one, and you look at it outputs, and this is a fairly normal thing to do when you're running solution templates in Azure. Each solution template will give you some useful output in addition to doing the work on your behalf. So over here, we give you actually a number of useful things. We tell you what the cluster name we created on your behalf is. We tell you what resource group we deployed to. We tell you what the cluster console is. And in fact, let's copy that right now. We tell you what the container registry URL is. We tell you what the generated project name is, and a bunch of other useful commands to actually begin the deployment and begin to interact with ARO. So these commands I literally have copied over into a script, and this is a script I'll be executing for you. Rather, wrong one. Apologies. And I'll be explaining what I am doing in the script. But really, believe me, this is really nothing much more than I just copied and pasted from the output, literally speaking, and made a few adjustments. That's about it. So first thing is first, let's go ahead and take a look at how our ARO deployment looks like. So I just logged in, and this is the Reza is the username I specified. I logged on earlier on. So here's my login. Once I log in, I'm told what do I have access to. So I have access to the registry, the internal image registry, which I'll be using to publish images. I'll show you that in a moment also. And also that I have access to this project that was generated for me. And this is where I'll be doing my deployments. So I'll go ahead and select this project. If you go to the operators and you look at the installed operators, you will see that there's an Open Liberty operator installed. And basically, this makes the operator is really what makes OpenShift aware of Open Liberty. So you do your Open Liberty deployments through the operator. The operator actually has a number of runtime controls over how Liberty is running in OpenShift. And you can even do things like distributed tracing and traces on dumps. So very few other Java runtimes have gone this far in terms of supporting OpenShift and supporting Kubernetes in general. Very few have operators. A really nice feature, as you'll see in just a moment. It makes the entire container experience a lot nicer than what it would otherwise be. So we can take a look at the rest of our resources here. We see that there is no pods. There are no deployments. If I go into networking, there are no services, no routes defined. There are also no build configurations or builds defined or images defined. So literally, this is just a clean room installation of ARO, save for the fact that we have these projects defined that we've defined for you in a secure fashion, and we've installed the operator on your behalf. So this is really all you're going to get, which is obviously quite a bit. If you were to do these same steps by hand, the operation to run the template is about 30 to 40 minutes. If you're do this by hand, it's easily you're going to spend a day doing the same thing, probably in a far more error-prone way. And in fact, what you can do, that's what you would do if you were running the manual guidance that we gave you. Okay, so we have that. Now let's begin to deploy the application. So here's the application, and this is an application that is actually available. If you dig around the manual guidance, there's a GitHub link. It's this very same application. So this is just a open microprofile and Jakarta EE application. It's extremely lightweight and very simple. It's just a RESTful interface. The only dependency I have is a provided dependency. And really, I'm just depending on the Jakarta EE APIs, and then really that's about all that there is to it. So let me go ahead and do a quick build of this application. So I'll do a clean. All right, and that is done. Let me do a install. Package is not an option in Eclipse for some odd reason, but install is. Okay, so what we got out of that is basically a WAR file. Okay, so there's my WAR file. And then just for sanity check, and in fact, this mimics real world and how you would go about doing development. We'll just run this. So I'll just say run on server, and this will start up my Liberty instance. And this will just start up in a few seconds. And this is a full-scale runtime. I've specified all of the Jakarta E8 APIs. So this is the application. It's not intended to impress. It's basically just a simple CRUD application. I will go ahead and delete an entry here for you. Maybe recreate that entry. Okay, and there you have it. Behind this JSF facade, there is a REST interface. Okay, so that's how the REST interface looks like. And I'll show you in a moment how to explore this a bit further using some of the microprofile APIs. But that's the basic application. In fact, that's all I really need to be doing in the IDE. So I'm just going to go ahead and shut down Liberty and shut down my IDE. The rest of the work I'll be doing is actually in the command line. So just exit this. All right. So here's the GitHub content that I have. First thing I need to do, and then I might as well begin copying and pasting from my script here. First thing I need to do is just do a Maven build. Okay, so this is just checks and balances more than anything else. This is actually already a Maven build that I did through the IDE, but I'll just redo it here. So just paste, Maven clean install. Already, and there's my WAR file. Okay, and now I'm going to build the Docker image. Okay, so I will execute this command, but I'll also show you what is going on behind the scenes, and I'll explain the syntax of what I'm doing as well. So in this case, I'm using Docker to build the image. You don't have to use Docker. You could be using Podman, what have you. Any container technology is really fine. Docker happens to be the most popular one. So the syntax here, and hopefully you can see my screen. In fact, let me just be on the safe side and increase my font just a tiny bit more. I know my eyesight certainly isn't what it used to be. Hopefully you can see that. I will check on you to see if you can. Otherwise, maybe Eyal can tell me if this is too small in terms of a font. But if everything is fine, let's just keep moving forward. So Docker build is referring to build the Docker image. -T is giving it the name. The name in this case is rather simple, Jakarta E Cafe. V1 is a version tag I'm giving it, and the dot refers to the fact that I have a Docker file in the current directory that basically tells Docker how to build this Docker image. So let's go ahead and build it and observe what happens. And I'll show you the Docker file. So let's hit enter. So this will go rather fast because basically what is happening is because of this is a Java EE app, pretty much all of the layers, and I'll show you the layers in a moment, all of the layers are cached because I just did this build just a few hours ago. So literally the reason this Docker image was built so quickly, if you've ever used to Docker, you'll know if you're using some other technology, this is not going to be as fast as this, even if you reran your build. But in this case, it's fast because the only thing that is really changing in this image is just a WAR file, which is just a few megs. Okay, so let me show you the Docker file. In fact, is this going to be visible enough? No, this is kind of ugly. So let me show you in the GitHub repo. I think it's a little bit nicer to look at. So here's the Docker file, and let me increase the font here. All right, so this is the Docker image. And I'll admit, in this case, I'm doing something a bit demo friendly. Okay, so you can see from my from clause, I'm directly getting the default Open Liberty image, and that comes with Java E8 basically. So it's sort of maximally what you can get out of Open Liberty. But Open Liberty is a modular runtime. It can modularize down to just a few megs if that's really all you want. But in this case, I'm being a little bit clever in terms of what's demo friendly and just starting from the base image. And because I'm doing that, the build winds up being a lot faster and more easily demoable. But other than that, I'm connecting to the database, so I will need the Postgres jar file. I'm putting that in the shared resources directory. I do have some server configuration. I'll show you the server configuration in a moment. It's relatively trivial, but there's a couple of interesting things to note there. And then finally, I'm copying over my WAR file, and that's about it. So now let me show you the server.xml. So here that is. And it's relatively vanilla. If you're used to Open Liberty, this will look fairly familiar. And again, I'm being a bit lazy, and I'm basically taking all of Java E8 as opposed to specifying exactly the specs that I need, which I could have done here. More importantly, I'm enabling microprofile health and microprofile open API, just to show you some of the capabilities, especially when it comes to integrating with container runtimes like OpenShift. Okay, so I've enabled microfile health and microfile open API, and that's really more or less about it, right? So I do have the data source configured, and one thing you should note here is these env variables, right? So the server.xml does not have a direct reference to these values. In this case, it's my database authentication and authorization information. I'm going to refer to those as environment variables and pass them in at runtime. Okay, and you'll see in a moment how that is. So that's my server.xml. Let's go back to my script. Next thing I'm going to do is actually exercise this Docker image that I created. It's a good validation step while you're doing container development, because instead of just assuming everything is fine with your Docker image once you've built it, it's always good to at least give it a smoke test. So that's what we're going to do. And I'll explain what I'm doing. And again, I'm using Docker, but you could be using Podman if you so wish. Okay, let me clear some of this. It seems a bit cluttered. Okay. All right, so let me explain the syntax here again. Docker run means run the Docker image. IT means interactive, run it in the foreground. RM means simply destroy this Docker image when I'm done. The -p commands is something you should note. So when you're running these Docker images, it is literally running inside of it its own virtual network. So a little virtual network running within your own machine. So you do not by default have access to that virtual network unless you expose ports. So in this case, I'm explicitly exposing port 9080 and port 9443, and that is how I can access this Liberty image externally, sort of from my own machine into this virtual network. The -e things are where I'm specifying the environment variables. And the last argument here is the image that I just built. So Jakarta Cafe V1 is the image that I just built. So let's go ahead and give this a run. Okay, so it is up and running now, and let's just do our little smoke test. So we'll go back in here. Maybe I don't need this browser tab anymore. Let's get rid of that one. And there's the app again. I do want to show you a couple of interesting things. So I want to show you first and foremost OpenAPI. So what Liberty does is when you enable microprofile OpenAPI, it actually takes whatever it basically more or less assumes that you're developing a single service, if you will, in a given one-to-one mapping between a Liberty runtime and a service, and it publishes whatever REST endpoints that you have and auto generates the the OpenAPI documentation for it. And actually, it even goes even further than that. There is a OpenAPI UI that is also shipped if you enable microprofile OpenAPI. So this enables you to actually sort of exercise the endpoints that are published in the OpenAPI doc. So let's say, I think you've seen the XML output before. Let's just say this time I want to see the JSON output of my runtime. I can try it out and say execute. And as you can see, this will tell you, what the output would be. Similarly, I could test out all of my method endpoints, so whether it's get by an ID or a delete or perhaps a post. Okay, all of that is possible. You can exercise all that. Another thing you should note is microprofile health. So if you access this URL, which is /health, it will basically tell you that this application and the server is in good health. So its status is up. Beyond that, you can also do check for liveness. Okay, and you can see that yes, it is in fact live, and you can also see that it is ready. And these are the endpoints that we'll be utilizing in our Kubernetes probes, and you'll see that in a moment. So this is what literally the endpoints that OpenShift will be using to make sure, hey, your service is actually in good health. All right, so let's leave that be the way it is. I'll probably reuse that browser for some browser tab for something. I can Control C now. Okay, and I think now we're going to get ready to. So far, we haven't done anything with OpenShift as of yet. So this is I just did a local build, local verification of my Docker image, but this Docker image needs to be in some kind of repository for something like OpenShift to utilize it. It needs to be in a registry. So the most convenient thing you can do is if you're using OpenShift is OpenShift actually comes built in with a bunch of stuff. So it comes built in with a CI/CD pipeline. I'll show you a bit of that in a moment, but it also comes with a built-in registry. So the built-in registry is the one that we'll actually be using for this demo. Okay, so let me stop for a moment, and before I jump into the remote deployment portion, let me just check on you to see if you have any questions. Okay, so I do not see any questions, so I will simply keep moving forward here. All right, so next thing we need to do is what we'll be using to interact with OpenShift is something called the OpenShift command line, or OC. All right, so we're going to, in order to run the OC command, you need to do a login. So this is a login that I'll be executing, and I'll show you how to get this login in just a moment. But let me just log in, make sure this works correctly. Okay, so I logged in, and you'll see this is more or less a text rendition of what happens when you log on into the OpenShift console. So it's telling me what projects I have access to. So the way you get this login information is you go to the OpenShift portal and you say copy login command. Okay, and I'll log in as myself. And this is literally the login command that I copied and pasted to log on onto my OC console. All right, so next thing I need to do is publish the image. So in this case, I'm going to be using a OpenShift capability called image streams. Okay, so an image stream is actually just a placeholder or indirection. You can, if you're a Unix person, you can, Linux person, you can think of this as a symbolic link. So we are creating a symbolic link or image stream, and the name of it is called Jakarta Cafe. This is the name that we'll be referring to in a moment in our manifest, in our deployment manifest. And then I'm specifying that I want to deploy to this project namespace. Okay, so and in this project. So let's hit enter. So this is now done. Let me show you what happened as a result of this. So if you go to the OpenShift console now, let's go and take a look at our builds and our image streams, and you'll see this was empty before. It's no longer empty. But if you look at it, there's nothing it is pointing to right at this moment. There are no tags. So this is just an empty placeholder at this moment. So next we need to populate this. So you populate this first and foremost by creating and running a build. So let's go ahead and create a build from the command line. You can do this via YAML if you so prefer. It really just depends on your preference. This is a bit easier to demo. So OC new build is referring to create a new build. The build name can be the same as everything else. So Jakarta Cafe is fine. I'm going to use Docker for this build, okay, because I'm building with a Docker image. And then I am specifying a tag in this case. So v1 is going to be the tag in addition to the image name. And I'm finally specifying what project I want to deploy to. So let's hit run on this. So this is giving me the ability to build an image now. So if you go back to the console and now look at build configs, there's now a build config, okay, created on my behalf. All right, it's telling me what the build configuration is. If you look at the image stream, this is still empty. Okay, so there is no image created as of yet. Okay, there is no image. You can see there is no image associated with the tag in the yellow flag, but there is at least a tag created for me. So now it's time to populate the image. You do that by actually executing a build. Okay, so let's do it. Let's go ahead and execute the build. You can do that, by the way, from the command line if you so wish. It doesn't make any difference. But I'm going to just do this here. Okay, and what this is going to do is that it is going to basically upload the contents of my GitHub repo and do the build remotely. Okay, so OC start build Jakarta Cafe from dir dot, meaning this current directory, and then giving it the namespace. So let's hit enter here, and this is unfortunately not cached for some reason. So I don't know why OpenShift does not cache remote builds, but it does not. So this is going to take a little bit longer than how fast our local Docker build was. I hope this is going to be fixed at some point. But as of now, we just need to wait a bit and wait for the build to finish. Meanwhile, let me check on you once again. Okay, there is a question. What would be the options for strategy other than Docker? Really nothing. Let me verbally answer this question if you don't mind. Let me see. How do I say I've answered this question? I'm not quite sure. I'll just leave it there. Okay, so there are a couple of different build strategies, but none of them are really suitable for using the operator. So the other option is source to image. So source to image basically works for things that are not using the operator. So if you're just doing a Maven build or a Python build or some other build mechanism, basically OpenShift understands how to handle that. Okay. The other one is custom, which I have never used. Supposedly, it's a pluggable situation where you can build anything you want. Docker simply is saying, do the image build based on the Docker file. So if you've ever heard of source to image, source to image is basically this other technology that we're not using in this case. In this case, we are simply building a Docker image because ultimately that's how the operator, the Open Liberty operator is expecting. Good question. Okay, so the image is built. Now let's go ahead and see how this impacted our deployment. So now you see that there is an identifier. So this is a real image. Now we're pointing to a real thing in the image stream. There's a build that was completed, and as you can see, you can rebuild this from here. It's perfectly fine. But now we can reference this image now, right, to do our deployment. And you can do the deployment using this command, using just a deployment descriptor. I don't prefer doing that. If you're very proficient with OpenShift, that's okay, but it's not really a very nice demo, to be honest. So instead, what I'm going to do is show you the graphical way of doing that through the OpenShift console. Okay, so the way you do that is we go back to our installed operators. We go to the Open Liberty operator. We click the first option, which is Open Liberty application. And then you'll see a button that says Create Open Liberty application. Okay, so once you hit Create here, it will give you a couple of options. Basically, you can either specify the manifest, meaning the instructions of what to deploy in a graphical manner, and we'll look at this in a moment. But you can also create the YAML view. And there is a sample Open Liberty application. It's the same sample application that you had the option of running in your through the operator. It's the exact same thing. But in this case, obviously, we won't be doing that. We'll be using our own manifest. So let me show you the manifest. Actually, this is not very nicely color coded. So let's take a look at the manifest itself. Okay. So first thing you'll notice if you've done Kubernetes-based development before is that this is not using Kubernetes primitives like service or deployment and the like. Instead, it is referring to the type of deployment as the type of as the type tied to the operator. Okay, so all of the syntax is going to be much more compact and much more targeted towards deploying Open Liberty applications. Again, this is very, very bleeding edge. Not very many other Java runtimes have this sort of capability just yet. All right, so kind of is Open Liberty application. You still need to give it some basic information like the name of the project and the name of the application rather, and also the project that you're deploying to, or the namespace you're deploying to, same one as before. I'm going to create two copies of the two replicas, load balanced replicas, or the two copies, load balanced copies essentially of my application. I'm going to, in the image, in the application image, I'm going to refer to the tag that I created before. Okay, so Jakarta Cafe V1. Expose equals true really does a lot of work on your behalf. What this does is that it creates a load balancer. It creates in Kubernetes parlance, it creates a service basically that's load balancing across these two replicas. And it is also putting a HA proxy, so a web application gateway in front of that service. So literally you have a internet accessible secure endpoint. Okay, so all of that work by just saying expose equals true. So you still need to specify the environment variables like I was doing before. And what I'm also going to do is a good practice for production environments, and that is to specify liveness and readiness probes. So if these probes were to fail, Kubernetes would know, or in this case, OpenShift would know, to automatically restart and kill or take a pod or node offline. Okay, so in this case, all you need to do is feed it basically those microprofile health endpoints. So that's what you're doing there. So now, and these are just some thresholds. So there's an initial delay of 15 and 30 seconds. You'll see that in action in a moment. There'll be about a 45-minute delay until this pod is actually made available. So I'm going to just copy and paste this guy. All right, and I'm going to get rid of the nice sample YAML here. And this is where you begin to understand the power of some other things that the operator does on your behalf. So once you go here, you'll be able to see all manners of different options that the operator supports. So obviously the name that was populated from my YAML, the application image name, the application name if you so wish, the application version, the pull policy, the pull secret if you're connecting up to a remote repo, expose equals true. Let's bump up the replicas to 3 just for fun. But you'll also be able to configure all kinds of things that the operator supports, things like auto scaling, probes. If you go into the probes, you'll see that my probes have registered here, but you could, sort of update this, and it gives you all of the capabilities that actually exist. So success threshold, and all everything that is possible to do with the operator. Similarly, you could be using stateful sets. If you have an application that is particularly persistent, like a database. This will give you the services. I haven't specified anything, but you could specify the services. The route, okay, so different strategies of how you'd like to do SSL termination, you could specify some of that if you so wish. So every single feature that the operator supports actually is in this form. It's a nice way of, I find that I often do the YAML development here, and then any changes that I make actually surfaces in the YAML file. So if I go back to the YAML, if I look at, for example, replicas, okay, this is replicas was incremented to 3 for me. Okay, so let's go ahead and do the actual deployment. So hit create. Okay, and the status should change to reconcile shortly, or at least I hope so. Okay, status is reconciled, meaning everything is good, right? It successfully did the deployment. Let's go look at the pods now. Remember, this was empty before. So these are running. The pods are already running. There's 3 of them, and 2 of them are already ready. Okay, meaning the probes have finished running. Let's just wait for this one last one. It should be no more than about 45 seconds before that happens. Okay, let me refresh just in case. Okay, let's get back to it. I'll show you the rest of it in the meanwhile. So there's 3 pods running. There's a deployment. If you remember, this was empty before. If you go into the networking, okay, you'll see that there's a service. Okay, so listening on port 9080. Here's a route that was created on our behalf. This is the internet accessible endpoint, which you can customize, by the way. So let's go back and take a look at the pod health. Okay, they're all running now. As you can see, 1, 1, 1, 1. So this my deployment is in good shape. Okay, so let's go to the routes and click. And there's my application. So I hit one of the pods in Open Liberty. So literally, we went from absolutely nothing, and just doing the Maven build on my local laptop, all the way to deploying to the cloud using the Open Liberty operator. So now let's do the undeployment. That's basically the end of the demo. And certainly I'll answer any other questions that you might have. Just to show you, how powerful some of this is, I'll just do a delete here, and you'll see the pods terminate. Okay, well, the pods are gone, and if you went to the routes, that's all gone. Okay, so we did a deployment and an undeployment within a span of a few seconds. So let me stop here, and I don't know if there's a way for you to have any discussion with me, but let me stop sharing for a moment, and then let you ask any questions that you might have. Otherwise, what I'll do here is I'll just share the documentation with you, the Microsoft Docs link, so you can go research more on your own. That's the easiest way to start.
I perhaps wanted to. I really like the demo and this kind of presentation. At least every so often, I think we should have one in the JAG. But when you, just more of a general question, when you have a service, you could, if you had several services, you could have had several of them on a pod or move them around, increase the number of services on the same pod, etc. That's correct from the graphic user interface.
Absolutely. And one of the more powerful things you can do is actually auto scale your number of pods, and you can specify that as an option of the operator. And you can even specify what threshold you would like to do, scaling up or down, in fact. So that's a very powerful capability. We basically, once you have the 40 cores and you have the uh, ARO install, it will basically utilize those resources up and down as you wish. So the typical pattern is to have one-to-one mapping between an app and a project. There are cases where people, have multiple apps in a given project. It can make sense if they're very closely related. But the typical use case is, if you have another service, you create another project, basically signifying a separate set of developers for that application. I would say that's the typical mapping, right? So if a project usually maps to a team in the real world, where there's an admin and then you assign a number of users to that project that are doing the deployment and the monitoring of the application. In fact, I didn't quite show you one feature that maybe I should have. You can actually monitor and interact with these pods in a nice way using OpenShift as well. It has a bunch of built-in monitoring capabilities.
Just to clarify, what happens with the database? Is a database inside there are multiple databases? Is it somewhere outside? Does it synchronize different databases?
It's an interesting and somewhat, I would say, gray area, right? So, in theory, yes. If you go to for example, OpenShift, and you go to in the OpenShift portal, if you open up what's called OpenShift Marketplace, you will see that OpenShift allows you to run databases within OpenShift. Personally, from personal experience, I don't recommend that. The reason is that the entire containerization technology is optimized for mostly stateless applications, stateless non-persistent applications. So it's very difficult when you have things that do very heavy disk access to have that abstraction layer. So typically, I actually recommend using a database path, just like I was, right? And I had my application running in OpenShift, but really I had my database running outside of OpenShift in its own managed environment. Similarly, if you don't want to go that route, don't want to use a PaaS, I, for the most part, would recommend just running your database on VMs. That's one area where VMs, in my opinion, still is king, because you get full control of what's going on. You get no abstractions between you and the disk, the underlying disk, and so on. All of those things matter when you're talking about data, as opposed to things like a Liberty, which is just mostly a compute platform. It's not really a data intensive component, if you will.
Okay. Do we have any other questions? I see that Bill Carlson joined us, by the way, which is nice to see you here, even though I can't really see you more than just your name at this point. But if we have no more questions, then thank you again. Thank
Yeah,
you.
no problem. In fact, let me share my contact details. If you folks have questions later on, I'm relatively easy to reach, or at least I'd like to believe I'm relatively easy to reach. But here's the URL for all of that. I just posted it in the chat. I should have posted it in the chat. My apologies. In fact, I do see a question, or rather a comment. But let me share both. I made the mistake of putting this in the Q&A rather than the chat. So in the chat, I just posted my contact information, and I also posted the link to the MS Docs. Okay, we are intending to eventually moving databases into OpenShift cluster, but have mixed results. Yeah, you're not alone in that, I would say. On balance, seems like it's more trouble than it's worth. Yes, I also agree that is in fact the real truth of the matter at the moment. I wouldn't venture to do that. I would keep everything that is very, very data and disk intensive out of the OpenShift cluster. In fact, I'd go so far as to say anything that is memory intensive should probably also stay out of the OpenShift cluster. OpenShift cluster is it has its own abstraction. It has its own way of managing memory. So if you have a extremely memory intensive application, let's say things that are doing things in memory that uses gigabytes of memory, okay, let's, or rather I should say hundreds of gigabytes of memory, and it's doing heavy in-memory operations, that's going to be difficult for a Kubernetes or a OpenShift to handle.
Okay, and I published, I hope people could see them, the links that you posted. I made them hopefully show on the stage, and they will show in the video. So this has been recorded. We will post it to our JaxJag channel sometime soon. And again, thank you everybody. Thank you, Reza. Hoping to see you at the JaxJag again in the future.